fourth question says that we have sine cube of 2x plus 1. And how do we handle this one? So sine cube, sine cube of anything can be handled in two ways. What are the two ways? Let's take a look at this particular question using one of the ways first. So I is equal to sine cube 2x plus 1. Now this is a linear function, linear polynomial of x. This will not create a problem. This sine cube is creating a problem for us for integration, right? And we can use an idea of substitution. What's that idea of substitution? That we can replace this sine cube, you can break the sine cube as sine square and sine. And you can write the sine square term as 1 minus cos square 2x plus 1. This is what you can write it as. Okay. This is sine square 2x plus 1 and there will be another sine of 2x plus 1 waiting outside. Okay. And now I can use substitution. What kind of substitution do we want to use? Okay, this is a complicated expression, but I can substitute cos of 2x plus 1 equals t. Once I do that, the derivative is waiting outside. Therefore, substitution will be useful. So what is the substitution? Let cos of 2x plus 1 is equal to t, new variable t. So the derivative of cos is minus of sine 2x plus 1. Then you need to differentiate this 2x plus 1 since we are applying the chain rule. This is 2 times derivative of x is equal to dt. Okay, I reach this stage and I realize, okay, this times this dx is present over here. And 2 and minus will go over here in the denominator. So I'll have minus 2 in the denominator. I can make this substitution and this integral will convert to 1 minus this cos of 2x plus 1 is nothing but t square. Okay, and this whole expression is dt upon 2 with a minus. So this is minus 1 by 2 in the product times dt. This minus 1 by 2 is not creating any problems. It will go outside the integral and we can easily integrate 1 with respect to t and t square with respect to t. So this will be minus 1 by 2 at the outside and integral of 1 will be t. Integral of t square will be t cube upon 3 plus a constant term. This is constant of integration, right? So we have this expression. Okay, let's multiply them together. This becomes minus 1 by 2 times t. And what is t? T is this expression, cos of 2x plus 1. Okay, then you have minus 1 by 2 and minus 1 by 3. That becomes plus 1 by 6. And you have t cube. T cube will be cube of this, cos cube 2x plus 1, and you have a constant of integration. This is the final answer for this question. This is the final answer for this question, but it is using this idea of substitution. We can follow another approach for integrating sine cube of something, right? Sine cube of that linear polynomial. So sine cube can be converted with the help of this particular result. Sine 3x is equal to what? This is 3 sine x minus 4 sine cube x, right? This is one result that we remember from trigonometry, that sine 3x can be expanded as this, and therefore sine cube x can be written as 3 sine x minus sine 3x. What I have done is I have brought this over here, sine 3x goes over there. There was a 4, I will divide with this 4. Okay, and this is the formula for sine cube x. What you have done is actually you have reduced the power and you get multiple angle, that is sine 3x over here. Integration of sine x and sine 3x are simple. Yes. So alternative approach of solving this integral could be I equals integral of sine cube 2x plus 1 dx. Okay. This tells me that I will further convert to integral of, there will be a 1 by 4 outside. Okay. And in the bracket you will have 3 times sine x, x which is 2x plus 1 over here, minus sine of 3x which is 3 times this angle. What is that? 3 times 2 is 6, x plus 3. This is what I get. Curly brackets closed. Yes, these are the two terms with respect to x, we want to integrate this. Now how do we do that? 1 by 4 is not creating any issue. 1 by 4 will come out. Integral of 3 times sine this, once again 3 is not creating a problem. Sine of something, integral will be equal to sine of x. The integral is minus cos x. So this will be minus of cos 2x plus 1, but you only need to take care of one thing. What is that? That we have to divide by this 2. Yes, divide by this coefficient of x over here. What else? This is minus of sine, so the integral will be equal to minus of cos. Minus of minus will become this plus 6x plus 3, and you have to divide by this 6, bracket closed, plus a constant of integration. That's the final integral. So this will simplify to minus 3 upon 8 cos of 2x plus 1, and what do you have? 1 by 4 and 6, this becomes 1 by 24 cos of, this is actually 3 times 2x plus 1, you can write it as 6x plus 3 only, but this is actually thrice of this angle plus a constant of integration. So this is another form of that same answer. What do you mean by another form? These are looking very different. Yes, these look very different, but if you observe, you can expand this by using the identity of cos 3 theta, and what you will get is that very same thing will come out. Right? That exact same thing will come out once you use this particular result of cos 3 theta. So you can interconvert between these two forms with the help of trigonometric identities again, or you can find the answer in this way, you can find the answer in this particular way. Now, this interconversion, I can leave it to you, I suppose. Yes, the identity that you will require is that cos 6x plus 3 is actually cos 3 theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. This is the identity that you will need. And just to give you a glimpse of the steps, let's write this. This cos 3 theta will be 4 cos cube. Let me write the term. 4 upon 24 will be 1 upon 6 cos cube 2x plus 1. So that's 1 upon 6 cos cube 2x plus 1. It's matched, right? The other term that you'll get is minus 3 upon 24. Okay, and that's minus 1 upon 8 actually times cos of 2x plus 1. Minus 1 upon 8 cos 2x plus 1 minus 3 by 8. So minus 3 by 8 minus 1 by 8 will add up to minus 4 by 8, which is minus 1 by 2 cos of 2x plus 1. They are exactly same. With the help of this simple thing, you can observe that. Yes. So both the methods are correct. Yes, both the methods are correct. Both the answers are also correct. And you can leave the answer at this stage, or you can leave the answer at this stage if you follow this particular method, this particular approach. That's the solution for this particular question.